No corrections at all. Thank you, Russell. And thank you, Emily, for the invitation to speak today, and to Jim Elling for his work, his role in setting up this presentation. I am really honored to have the chance to speak today, because this work has involved a great many people, and all of them have really valuable points of view, and I'm honored to be the one to get to talk about this project. And want to make sure to thank Dan Shapley and Sebastian Pelletieri for being on my team at Riverkeeper. And I'm curious if anybody here is, or anybody here today is from the Pecanico or the Salmo River sampling team, because they are out sampling today. So if you are, thank you. And thanks to everybody who's a sampler who's out there today, who's participated in our water quality program. So I'm going to begin with what we've learned about water quality in the Sparkill Creek. And I'll start with recent work, the most recent work that we've done, and that had a focus on water quality assessment, a project that Riverkeeper and Sparkill Creek Watershed Alliance recently completed. So Sparkill Creek Watershed Alliance has been bringing in a variety of partners to study the creek since 2011, including Riverkeeper. In 2019, we had the occasion to sit down with several contributors together and to look at the status of sewage pollution studies in the creek. And at that time, folks from DEC, Division of Water, suggested to us that a water quality assessment would be a worthy project that could help to move the needle in the watershed. So Riverkeeper took the lead on that and got a grant from the Hudson River Estuary Program to complete a water body assessment, a water quality assessment in the watershed. We did this through the DEC Peers program, which enabled us to get a DEC-approved co-op and to work with the agency on the methods and the study plan to ensure that our results would be acceptable for agency use. So Peers was retired mid-project, is now defunct, but the folks at DEC continue to work with us to wrap up the project through, right about now, actually, we're finalizing the report and such. So the goal of this was to collect enough data of approved quality to update the water body assessments for the entire Sparkill Creek watershed. Why do we care about these assessments? They're important documentation of the condition of the stream. They're used to determine eligibility for state programs. They're used to rank applications for state grants. And in the Sparkill Creek watershed, the assessments right now, prior to acceptance of this new data, are either non-existent or needing verification, or are aging, getting fairly old. So we set out to produce a new assessment with the belief and the understanding that DEC would use the data in ways that would support our goals as Riverkeeper and Sparkill Watershed Alliance. Namely and specifically, we want to help municipalities to compete for funding and assistance for water quality improvement projects. So this slide has a list of the water quality parameters that we tested. You can see that fecal indicator bacteria, which I talk about a lot, are not on here. They were out of the picture for this project. And also not listed are macroinvertebrates, which DEC had their professional staff come and sample once in 2011, and we'll be doing again this year. I don't have access to those data, so we're not talking about those either. So our methods, Riverkeeper and the Sparkill Creek Watershed Alliance completed sampling in 2020 and 2011. We completed 8 successful sampling events. I want to give a huge thank you to Carol Knudsen, who did a tremendous amount to support this. She did a lot of field work and helped us with the our field probe. John Abitangelo also did a lot of field work. Jim Elling, the same. Matt Seplow and Zoe Barkin-Nelson, all of those people came out and really contributed to this project. And as I said, we had a DEC approved co-op, and all these samples went to ELAB certified laboratory for analysis. So these results that we're going to look at today are preliminary. They haven't yet gone through DEC's quality checks. And I want to mention that, as I said, the project was funded in part by a grant from the New York State Environmental Protection Fund through the Hudson River Estuary Program of the New York State Department of Environmental Conservation. Here's a map of the Sparkill Creek watershed. So the stream originates in the mountains at the northern end of the watershed, and then it flows south through very densely developed land, dips into New Jersey. And because this map uses layers from New York State, the line just disappears into New Jersey, but it continues and then comes back, and a tributary called Sparkill Brook joins right past the New Jersey line, and then the creek flows into Piermont Marsh where it becomes tidal, and that tidal section wasn't included in this work. So on this map, the stream segments are color-coded. There are 4 stream segments in the Sparkill Creek watershed. These divisions are for regulatory management of the stream. And you have the upper Sparkill Creek, which is the purple color. You have the lower Sparkill Creek, which is the green color. And then you have tributaries. You have tribs to the upper, which are these light blue lines. And then you have tribs to the lower, which are these orange-red lines. And we covered all 4 of those segments in our monitoring plan. I'm going to go through the highlights of the data for like 10 slides. And each of them is going to have the same format. The average values are these large gray dots. So that's the average of all the samples that we took. And like I said, we had 8 successful trips. In some cases, we have 1 or 2 more data points than that. So 7 to 10 samples per site. We lost a few too. So the large gray dots are averages. And then the maximum and minimum values are these smaller black dots. And the segments of the stream are labeled at the bottom. So you're looking at the upper main stem, upper tribs, lower main stem, lower tribs, and all these charts. And where there are red lines, those are showing either New York State water quality standards or EPA recommended water quality criteria. And I will mention which is which and talk more about the significance of difference of those later in the talk. This is a broad overview by segment. We have a report, it's on our website, and I'm going to share the link with Emily so she can share it around. And it delves more into site by site and has other kinds of looks at the data. So I recommend, if you're interested, everybody take a peek at that. So starting with pH and temperature, there's a really great section on the USGS website. It's called Water Science School. And so I put in links to each of these parameters there for people who want some really good background on just, water chemistry. So pH and temperature are both 2 really just basic, important physical parameters of the water. pH determines the solubility and the availability of chemical constituents in the water, and temperature exerts a major influence on growth and the rates of biological processes. So 2 just kind of important basic parameters. And what we found is that pH is consistent along the stream. It's at the lower end of the acceptable range. This is the New York State Water Quality Standard. So pH should be between these 2 lines. Excuse me. And it is, but it's toward the lower end. And temperature is fairly consistent when you group it by segment as well. The stream does get warm. 25 degrees Celsius is like 77 degrees Fahrenheit. It's like bath water. It's pretty warm, and that may be because of paving, and it may be because of lack of shading vegetation. It could also be there's some commercial industrial discharges, so we don't know exactly the reason for those warm temperatures, but it does get warm. Specific conductance and chloride are next. So specific conductance is a measure of dissolved salts. Chloride is one of the components of specific conductance, and chloride is toxic to aquatic life at high concentrations. And it's pulled out here because a major contributor of chloride is road salting. So specific conductance, a general indicator of human impact, lower is better. And the lows and highs that we see here show us hotspots. And when you look site by site, you see that even more clearly. And so these can help us prioritize where to focus on water quality improvements. Chloride, this is an EPA recommended criterion. it's for chronic aquatic life effects. So the highest value that we observed was above this line, but probably the more relevant is the average value. And the average values were below there. Chloride is increasing in streams nationwide, though, and again, that's largely due to road salting. Carey Institute of Ecosystem Studies and the Thirst Network of Streams have done a lot of really great work on chloride here in the Hudson Valley locally, and are good resources for looking into chloride more. Dissolved oxygen and turbidity. So dissolved oxygen, just necessary for life, right? Aquatic organisms live underwater, but they still breathe oxygen. And then turbidity is a measure of the clarity of the water. And turbidity can be caused by sediment, or it can be caused by algae, suspended algae, some mixture of the two. But high turbidity can harm fish. It can provide attachment sites for different pollutants, and it can also block light from penetrating into the stream to support photosynthesis. So on the left, we have dissolved oxygen, and this red line is New York State's water quality standard. And dissolved oxygen in all the segments was above the New York State standard, which is good. You want to be above that line. But the lower values are concerning. They're getting low. The lows are low. And turbidity, this is an EPA recommended criterion. The average was below that recommendation, which is good. In this case, you want to be below. But as with dissolved oxygen, the extremes are concerning. So in this case, those maximum values are above those lines. And, you know, with turbidity, because turbidity can be caused by precipitation, rainfall runoff, as the climate changes, as we have more large rainfall events, we may have more sediment coming into the stream, and this may change. And so this is a good warning signal to focus on reducing the turbidity in the stream. And then we get into the nutrients. We tested a variety of different nutrients, but we're just going to look at total phosphorus and total nitrogen today. These nutrients are both essential for plant life. Too much of nitrogen and phosphorus cause eutrophication, so the growth of excess plant life. Typically, it's algae. Sources are manure, sewage effluent, industrial effluent. In the case of nitrogen, it can come from fertilizers. Phosphorus fertilizers are not allowed to be sold in New York. And EPA has recommended criteria for total phosphorus and total nitrogen. New York State does not have numerical nutrient criteria. And the Sparkill Creek, all the segments of the creek are above these EPA recommended criteria, with the exception of the upper tribs for nitrogen. And the values get really high compared to where we want to be. This is a clear sign that there's excess nutrients in Sparkill Creek. And chlorophyll A is the last parameter I'm going to show you. This is a measure of the algal biomass. In this case, this is the suspended algae in the stream. So as these nutrients contribute to algal growth, chlorophyll is a measure that can help you to see whether that nutrient enrichment is leading to excess growth of algae. And in Sparkill Creek, we do see that chlorophyll A levels were above the EPA recommended level in all the segments of the creek. So this is a symptom that the nutrient enrichment in the creek is having the consequence of excessive growth of suspended algae. And the chlorophyll increases as you move downstream. I think this is an erroneous data point, and as I said, the data review hasn't been done, so I don't know what whether this would be excluded as an outlier or what, but I just want to point out that that seems quite high, because that day the water looked extremely clear. And if you eliminate this point, the average does decrease a little, but it's still over that threshold. Before I jump into takeaways, which are next, talk about takeaways next, I just want to emphasize the value of this data set. As I mentioned before, a lot of volunteers' hours went into producing this data. This is available for everyone to study and use. We have it stored on a Google Drive, and we truly and deeply hope that DEC is going to use this to update their assessments, but anybody can use this data to explore relationships and questions about the creek, and we hope that they will. It's a really huge asset and a big accomplishment for the Sparkill Creek Watershed Alliance. So I just want to pause and acknowledge that. The results of the assessment, though, are not deeply surprising. They're informative, they're interesting, but they're close to what one would expect. And why is that? We've been testing the Sparkill Creek for indicators of wastewater contamination since 2011. And based on those results, we know that there is sewage in Sparkill Creek. We know from looking at maps that major sewer trunk lines flow along the stream corridor. And we know that wastewater contains high levels of nutrients, large amounts of nutrients, and other chemical compounds that can degrade water quality. Second of all, this watershed is heavily developed with residential, with commercial, with industrial land use. Prior to all of that development, this watershed would have been covered with natural vegetation. Removing that vegetation and paving removes the shade from the stream. It leads to increases in the temperature of the stream through direct penetration of sunlight and through warmer runoff. It changes the base of the food web because forest leaf fall is a really important food source in forested streams for insects. And when you remove that, you change the biology of the stream. Pavement blocks water from infiltrating into the ground and flowing underground. And that changes stream flow, it changes stream temperature, it changes turbidity, erosion, sedimentation, changes pollutant loads. So it's not surprising to see these impacts. It's called the urban stream syndrome in the academic literature, and that syndrome refers to a predictable set of impacts of basically increasing impervious surface in a watershed. And then finally, salinization is a national trend. And if you look into studies of stream chloride levels over time, and by region, you can see similar levels to what we saw in the Sparkill Creek. So these results are not shocking. They're interesting. Like I said, they're super informative and very useful, but we shouldn't be too surprised to see what we see. Saying that is not the same at all as saying that this is the way that things should be or that they must be. In fact, I'd say we should look at this and say we know better, we can do better. And this is where we start to examine the gap between the values of our watershed community, I'll call it. So Riverkeeper, Sparkill Creek Watershed Alliance, for sure. Probably many people here today. So there's a gap between our values, our expectations for what the health of the creek should be, and the observed response and the observed actions that we see from regulatory and municipal actors. And I want to be super clear that I'm not trying to say every individual at every agency or municipality is bad. I'm saying that the system and where momentum builds and where it doesn't is not matching up with what we want to see. And so we've worked with fabulous people at multiple agencies, state, federal, local, municipal. And I know that many people want the same things for the creek, but the truth is that the momentum isn't there. So I think in the talk description, we said something about the promises and limitations of community data. I think really the issue though is just data, like the promises and limitations of data. And it's interesting to kind of go back and think about the start of the Sparkill Creek Watershed Alliance here. So the alliance was started by Lori Seaman in around 2011 because a kid called on her to do it. Lori's an educator. She brings students to the water all the time. And back in 2010, she was bringing students to waters, all kinds of waters around Rockland County, water treatment plants, wetlands, mountain streams, lowland streams, all kinds of places. And one of them was Sparkill Creek, and Lori was there with her students. And one day she and a close student were kind of working together, and the student said, Lori, tell the adults the water smells nasty, and the kids know what they're not doing. And this kid understood that the creek wasn't healthy. The kid had seen with their own eyes various water bodies around the region, and they knew that it shouldn't be this way, and it doesn't have to be this way. So Lori started the Sparkill Creek Watershed Alliance. Here we all are. Thank you, Lori. And once again, it's worth pausing to acknowledge the value of that group and how valuable and how powerful they can be for the creek. So then if there's this gap between what we want to see happen and what's happening, how do we get here? Don't we have laws to protect the water? And yes, we do. We have the Clean Water Act. Clean Water Act is a federal law. It sets out a framework for how states must manage waters. And states have a lot of latitude over the details, but the framework is set in that federal law. So there's two parts that really bear on the discussion today that have to do with monitoring and assessment of the water. And so they are water body classifications. Those set the goals for the water quality. This creek, we say, should be usable for drinking. It should be suitable for swimming. It should be suitable for aquatic life. You know, we decide which of those, and those goals are ranked. And then water quality standards are set, and they are used to assess whether the stream or river is meeting the goals. And so New York State sets both these classifications and these standards. EPA issues recommendations, but they can't force New York State to adopt their recommendations. They can't force New York State to adopt any particular standards. They do have some power over approval, but they can't force the state. And so this is a big problem in New York, and is a problem in Sparkill Creek, and our assessment really highlights why that is. So here's what the Water Quality Act, Clean Water Act's classifications and standards look like for Sparkill Creek. The stream is classified as either Class B or Class C, depending on where you are in the watershed. So that means we've said this stream should be suitable for swimming in some locations, and in other locations, it should be able to support aquatic life. Water quality standards can fall into two broad categories. So there are numeric standards and there are narrative standards. Numeric are what they sound like. They are specific numerical limits that say, this is the line where you have too much or too little of something in the water. And that's what we were looking at in the graphs earlier. Examples for this watershed for Class B and C waters are dissolved oxygen, pH, total and fecal coliform, and then there are a long list of other things, including dissolved solids, specific metals, a lot of different toxic, potentially toxic compounds, and more. Narrative water quality standards are descriptions. They often have the phrase none in amounts that will impair the water quality for its best use. But the trouble is that amount is not specifically defined. And so it's difficult and it's much less clear than it is for numerical limits. Lacking numerical water quality criteria for nutrients in particular is a hindrance. Nutrients are a really important driver of algal growth and biological activity. Without numerical nutrient standards, we do not have clarity on how much nutrients are too much, and the standards are less protective because they only kick in once you're actually seeing the negative symptoms of nutrient enrichment, rather than acting based on concentrations before you start to see things tip over into really poor conditions. EPA has recommended numerical criteria for phosphorus and nitrogen, as well as chlorophyll and turbidity since the early 2000s. And New York State is working on standards, numerical nutrient standards, but hasn't adopted them. And we need them. We really need them. And especially in the Sparkill Creek. If New York State adopted reasonable numerical criteria for nutrients, we would have much better tools to protect water quality. And here in Sparkill Creek, they would make the difference between concluding that the stream is kind of doing okay based on this assessment, or the stream really needs help. And so let's just kind of look at why. So going back to the data review, as mentioned, the stream meets the pH and dissolved oxygen standards. And so from the assessment data that we collected, we can look at this and say, okay, well, things are things are looking okay. Things are looking good. Once we start to compare to EPA's numerical recommendations, which New York State could adopt, we start to see evidence that the water quality is poor. So those turbidity levels where we see those maximum values exceeding thresholds, and then for nutrients, for chlorophyll, a clear signal that there's eutrophication in the stream's showing a biological response to excess nutrients. And so the narrative nutrient standard doesn't reveal this because we're not seeing excess amounts of nutrients in levels that lead to, say, harmful algal blooms yet. We have a very similar situation with regard to fecal indicator bacteria. So for those portions of the stream that are classified as B, which are supposed to be safe for swimming, fecal indicator bacteria would be the primary measure of water quality. And EPA in 2012 set forth recommendations based on best available science, indicating that states should use Enterococcus or E. coli to assess whether water is safe for swimming. New York State has not yet updated those criteria. They're still using 1980s era indicators. And Riverkeeper and Sparkill Creek Watershed Alliance have measured Enterococcus in Sparkill Creek since 2011. This chart shows a subset of the data at locations that we've sampled in the Sparkill Creek continuously, 4 locations in the main stem that we've sampled continuously since 2012. The average, the geometric mean, the average values of enterococci are very far above the EPA's recommended threshold. The red line shows that threshold, right? So we can see the creek is obviously polluted, and the sources are certainly complex. And this magnitude of exceedance seems to indicate an urgent situation. And in 2021, we also tested for E. coli, and the results, the conclusion was similar based on those results. One of the really interesting things that we are able to just now start to really see after 10, 12 years of water quality sampling is that on average, the entero counts have been more or less declining in Sparkill Creek since we began sampling. And because of these peaks and valleys, it really is after a long time that you start to really be able to see this clearly. I mean, imagine just put your hand over 2019 to 2021, and you kind of don't know what to say. So we don't really know why this is happening, but if we could figure this out, it shows us something, perhaps, you know, some direction we could go to support this trend, because this is a trend that we do want to support. This is a good thing. As mentioned, the sources are complex. Sparkill Creek Watershed Alliance has done a tremendous job of acquiring public and private funding and of bringing in collaborators, partners from NGOs, from agencies, from academic institutions, including Riverkeeper, to track down the sewage pollution in the creek. And those studies have shown that there's human poop in the water. Sparkill Creek Watershed Alliance has worked with Queens College to single out and search for DNA of human-specific bacteria, and they have been found to be present in the creek water. Entero and E. coli counts have been shown to be comparable to the largest CSO in New York City. And Entero has shown to be associated with pathogens and with antibiotic resistance. So this human poop in the water has significant consequences for human and aquatic life. So on this anniversary of the Clean Water Act, it's at 50 years since the act passed. That passed in 1972, it's now 2022. We've been monitoring in Sparkill Creek for give or take 10 years. So that's about 20% of the lifespan of the Clean Water Act. And the goal of that act was fishable and swimmable water everywhere, nationwide. And it's beyond a doubt that significant improvements have occurred in water quality. There's no question about that. But it's also apparent that in some places, like in the Sparkill Creek, the law is not managing improvement, it's more managing decline. And this is one of the widely acknowledged limitations of the Clean Water Act, is that there is a lack of federal mechanisms to really force states to take action. So we see poop is in the water. And we, I think, interpret the data. We, Riverkeeper, I think, interpret these data as indicating that there's an urgent situation that needs action. But we haven't seen Orangetown do sewage leak detection in the Sparkill Creek watershed as they have successfully done elsewhere within the town. We haven't seen DEC come and measure fecal indicator bacteria to verify our results. We haven't seen DEC begin to create clean water plans for the portions of the stream that are already listed as impaired. We haven't seen New York State adopt water quality standards that are up to date and that are protective. So Riverkeeper's role going forward, we are advocating at the state level for numerical nutrient standards, for modern bacterial indicator standards. We are in the midst of a legal action to ensure that all the waters of New York State are held up to that goal of swimmable. Right now, this is in the courts and it is limited to saline waters. There are some classifications of waters that do not indicate swimming as a designated use, and they should. So once the saline waters case wraps up, it will have implications for the analogous situation with fresh waters, Class C waters like we have in Sparkill Creek. And Riverkeeper has advocated long and hard for the legitimacy of community-based data and will continue to stand up for the legitimacy of community-based data. For the watershed, we have some huge accomplishments. We have a lot of good information. There's a huge difference in knowledge and data between 2011 and now. Part of this is that the Sparkill Creek Watershed Alliance is a 10-year-old plus organization that has continued to meet. It has deep roots, it has great partnerships, it has relationships, and their continued effort is a major accomplishment, and it's a real asset to the watershed. We at Riverkeeper have been heavily data focused in the Sparkill Creek watershed for 10 plus years. And the work has really exposed these gaps between our watershed community expectations and the observed response of the systems that are set up to protect the water. And there's a lot of reasons, a lot of them are very reasonable and logical reasons, but there's a lot that needs to be done, and the creek deserves better and it needs more. And so one really positive step that I want to draw out and highlight and end with is that Sparkill Creek Watershed Alliance is applying for support to complete a watershed characterization, which is a document that would pull together all the information that we have about the watershed, kind of zoom out and take the time and the effort and the space to put all the pieces together. And that would be a tool that could bring everyone together to engage in watershed planning, the big picture level, and think creatively about new approaches. So I am excited to hear people's questions and comments and conversation. That's all I got.
Great. Thank you so much, Jen, for your presentation. It's so exciting to see the culmination of a decade's worth of work and data and pulling together all of these pieces. So thanks. And thanks so much for being here in the midst of a very busy time for you. So
thank you. Well, should I stop the screen share?
Up to you.
I'll leave it in case people have questions that we want to go back to.
Great.
Exactly.
Thanks.
Okay. So our first question is about the time frame of the data that you've been discussing. So I know there's the two different projects, there's the peers and there's the enterococcus. Could you talk about the time frame, the duration covered, and then how many samples are collected annually that represent these data?
Yeah, peers took place over 2 years, and we were aiming to have 4 successful sampling events in each of those years. And by successful, I mean that our samples were successfully delivered to the laboratory, which didn't always happen, and that the samples, when processed at the laboratory, passed sort of our initial screen of quality control checks. We mainly looked at our blanks and just checked that they were indeed blank for most parameters. So in the end, I think we had 3 events in 2021 and 5 in 2022. So as I said, in some cases we had some parameters on an extra date that we did successfully collect. So the range of number of samples there is like 7 to 10, and in our report, it's more clearly laid out. I kind of went fast through it today. For Enterococcus, sampling began in 2011 at a certain number of locations. I think they sampled 3 times in 2011. I generally take 2012 as the start of the sampling program, because in that year it began May through October, once per month. I think in 2012 we had 18 locations in Sparkill Creek, and over the past several years we have reduced the number of sites. And so in the graph of entero data that I showed, we were looking at a subset. It was 4 sites that have been sampled continuously since 2012. And it totals to 232 samples in that figure. This is the same set of samples. So some different combinations of data. We use different combinations of the data set in different situations.
Great.
I hope that helps clarify that question.
Has there been any work done in the Sparkill Creek watershed looking for point sources of pollution?
Yes, we've done outfall monitoring and have reported a few different cases to the town of Orangetown. In I'm not sure of the date. I want to say about 2018, EPA came and did a full audit of the MS4 program in Orangetown. And so that included the Sparkill Creek watershed. And that audit took into account some of our sampling data from the lower portion of the creek, where there was a discharge from a plant that produces tofu. And in other situations, we've seen groundwater flows from stormwater outfalls, so continuous dry weather flows, but without high Enterococcus counts. One of the challenges with point source tracking, I will say, is that for the MS4 program, it's really like a sniff test, a visual test. And so we've seen in instances water that looks clear, that smells okay, that has high entero counts. And it's difficult to force action in those instances.
Great, thank you. Were you able to determine how big a role stormwater runoff plays when it comes to turbidity or maybe some of these other pollutants?
We didn't try to tease out the specific causes of turbidity or other pollutants. And I think that's one thing that could be still, this data set could still be mined to do that. It'll be difficult with runoff because we only have one true wet weather sample in there. This is mostly dry weather data. But in terms of season, maybe, one could go in and look seasonally. So no, that wasn't something that we did yet.
And I'll just add that years ago, the Sparkill Creek was planned to be a pilot for a model that DEC was going to be helping with, looking at land use and thinking about bacteria inputs. And so I'll just add that I think that data might be out there somewhere from some preliminary modeling that was done. And that's the kind of question where modeling might be really helpful in addition to the in-stream data. So just had to add that point.
Yeah, yeah.
Okay, great. Can you repeat the details on the specific issues that Riverkeeper is currently pursuing through litigation regarding New York State water quality standards, and what specific parameters are involved, and what is Riverkeeper pushing for the state to do?
Okay, So I am not a lawyer and I am not involved in this case. I'm going to give you my best understanding. There are waters that are saline water classifications that are SD and I, and those classifications do not state swimming as a designated primary use. And the state set forth for those classes of waters proposed fecal indicator bacteria standards. And so that allowed that by setting that forth, it requires an EPA approval, and that allowed Riverkeeper to take action. And the action that we took is to state that those classifications should have swimming as a primary designated use. And so that's what is at issue, is whether, because the Clean Water Act states fishable and swimmable as a goal and as a standard, whether you can have waters that don't include swimming as a primary use. And the analogy is to fresh waters, where you have class C and class D waters. They just use different letters. And those in the classification definition state that aquatic life support is the primary use, and that there may be swimming depending on certain factors, certain physical factors.
Great, thank you. I want to bring everyone's attention to the chat for a moment because we've got some great resources that are being shared, and I will put these in the email that goes out to everyone so you have them. But there's reports on bacteria and Riverkeeper's data that's available for other uses, and also a flood study that was just completed on the Sparkill Creek through the Resilient New York program. And so jumping off of that, there are several dams on the Sparkill Creek that no longer serve a useful function. I'm guessing those were identified through the flood study process. Can you comment on how their removal might influence water quality?
Yeah, so dams in streams take a free-flowing system and block the flow of water and impound the water, so that you fundamentally alter the ecology of the stream. A flowing stream is more variable. You have changes in flow over the seasons and with precipitation that get sort of smoothed out when you have impoundments, and it slows the flow of water, so the water warms up, and there's more potential for the growth of algae in the water. And you have different types of insects and fish and other animals that are suited to the habitat of an impounded water. So if you remove the dams, you would free the flow of the water and restore the creek to a more natural condition, and promote the overall health of the creek by creating a habitat that's more similar to what native wildlife are evolved to live in. Dams block the passage of organisms up and down the stream, and so they segment and fragment the habitat as well.
Great. And in the Sparkill Creek in particular, are there any parameters that you think the dams would be influencing in this watershed?
I'm not familiar with the dams in specific in the Sparkill watershed, but they certainly can influence temperature, they can influence chlorophyll, they can influence dissolved oxygen, because if you have more suspended algal growth, first of all, that algae creates a lot of oxygen where it's growing toward the surface, but then when it dies, it settles to the bottom and decomposition consumes oxygen. So you can have oxygen depletion at depth. I don't know that these impoundments are deep enough to have that kind of a stratification. Again, not familiar, but the dams can block the passage of sediments. So sediments will collect behind the dams and will not make their way downstream to be deposited elsewhere. So you sort of change the erosional depositional regime of the of the stream. Those are broad strokes. I don't know the specifics of what's going on in this creek, but those are like general impacts of dams.
Great, thank you. Are there any wastewater treatment plants discharging effluent that might be contributing to the contamination in the Sparkill Creek?
There are two very large wastewater treatment plants in the watershed of the Sparkill Creek. There is the Rockland County Sewer District #1 treatment plant, and then there's the Orangetown wastewater treatment plant. And the combined volume of those two plants is regionally significant. It's a large volume of wastewater. The discharges for those go into the Hudson River. That pipe travels out under the water, and the outfall is in the Hudson River. So there aren't discharges of treated effluent into Sparkill Creek. What there is a large network of collection system. So you have large trunk lines coming through the creek corridor leading to those wastewater treatment plants. And then you have all the network of pipes that carry the wastewater from homes and businesses into the wastewater treatment plants. Those pipes, some of them are very old, some of them are made of clay. And over time, if they are not maintained and repaired, they can begin to degrade. They can begin to crack and break and leak. If anybody has ever called Roto-Rooter to come and fix a blockage in their leader line, they'll know that tree roots can penetrate into these pipes. And typically what Roto-Rooter does is just remove the part of the tree root that's blocking the pipe. It doesn't repair the actual entire pipe. It just removes the blockage. And so at a large scale, it's conceivable that there are leaks within that system. There are industrial and commercial dischargers directly into Sparkill Creek. So that's another area where those facilities all have permits which regulate what they can do, when they can discharge, what volume of water they can discharge, the concentrations and types of pollutants they can discharge into the creek. That's all regulated, and one could go and look all that up and see exactly what sorts of discharges are happening from those places.
Great, thank you.
Yeah.
What efforts have been made to engage communities along the creek, like residents, property owners, businesses, and so on, to take an interest in its stewardship? And I know we've got some members of the Sparkill Creek Watershed Alliance who are with us in the chat, but Jen, since you have the mic, any efforts on community engagement for stewardship?
So Riverkeeper, we've mostly been focused at the town level, working with Sparkill Creek Watershed Alliance. I can't speak to all the engagement that the Alliance does because they have many relationships with many people in and around the town and county. But I can say that so one of the things we really want to see happen, one of the big actions that we really want to see the town take is we want to see the town do a sewer leak detection project that focuses on the portions of that wastewater system that are within the Sparkill Creek watershed. They've done this in Nyack with good success. So they use closed circuit television, they use dye testing, they may use smoke testing, they use old-fashioned boots on the ground, walking around, testing outfalls, as was alluded to before in one of the questions. And they've done this with success in Nyack, and we want to see them do it in the Sparkill Creek watershed. And so one of the things that we did was that Sparkill Creek Watershed Alliance worked with Riverkeeper to make a presentation to the town board to formally request this. And this is an idea that actually came out of the town sewer department staff. So this is not something that we dreamed up. This is something that they put forth as within their capability and a potential solution. Another really big moment was in 2019. As I mentioned, we brought together Riverkeeper, EPA, DEC, the town of Orangetown, Lamont Doherty. I think Greg was there from Queens College, Sparkill Creek Watershed Alliance, all came together and DEC, to really look at our sewage monitoring and source tracking work and to think about like steps forward. And so that was a big moment of engagement, and that's what led us down the road of doing this water quality assessment, which has been a big step, right? A big accomplishment. It also led to Sparkill Creek Watershed Alliance working with CUNY Queens College to complete 2 years of DNA-based source tracking in the creek. So there have been some really successful moments of engagement, and I can only speak to a portion of them.
Thank you.
I had two questions. The conventional thinking is that harmful algal blooms are triggered by high nutrients and warm water. But we didn't talk about HABs. The other thing that's typically triggered by nutrients, by bacterial growth and warm water is collapsed DO, and the DO wasn't terrible. Any thoughts on both of those concepts?
Yeah, I should have mentioned HABs. And this goes back to the dam question too. We did test for chlorophyll, and that was the suspended algae in the water. And we did see that chlorophyll was above the levels that EPA has set forth for recommendations. And so I think, and we saw high nutrients, nitrogen, phosphorus. Phosphorus is considered to be the main driver of algal growth in freshwaters, but nitrogen absolutely contributes as well. So I think what you see in the Sparkill Creek are conditions: warm water, high nutrients, some indication that chlorophyll levels are pretty high. You kind of see the recipe for harmful algal blooms. And the question is, will they happen or won't they happen? Right? I don't know. Certainly, riverine harmful algal blooms are less common than in lakes because you have flowing water, which moves organisms out of the system and prevents blooms from really taking hold and taking root and blooming. But we did see in the Wallkill River in 2016 harmful algal blooms that were long-lived. You know, a harmful algal bloom that lasted 60 days and covered cumulatively 30 miles of that river. And so I think it's totally possible. I mean, I think that's the kind of situation we want to avoid letting happen in the Sparkill Creek, where you let nutrient inputs reach levels where you have super high nutrients, you ignore warning signs that chlorophyll levels are high, and you get to a situation where you've got harmful algal blooms. Once the algal community sort of tips over into a point, or the stream ecology tips over into a point where harmful algal blooms are occurring, it's difficult to reverse it. It's much easier to prevent nutrients from coming into the stream and enriching the stream in the first place, to prevent communities from degrading to the point where you have an excess of cyanobacteria, which cause harmful algal blooms. It's much easier to prevent these things than it is once you have them to dial back the clock.
Oh, thank you for those thoughts.
Oh, and climate change, right? So as temperatures increase, we're going to see stream temperatures get warmer. The prediction for this region is that we will have larger storm events, you know, more frequent large storm events, which deliver high loads of nutrients into the stream. And so that's kind of another component of the warning signal. Is we see that we're heading toward a situation where you can have, you know, really harmful algal blooms conceivably happening in Sparkill Creek, and we have climate conditions that are going to continue to promote it. So
my other question, and we're almost out of time, I apologize, but I think I heard that Malone and McBroom, now SLR, has also been doing some kind of a project in the Sparkill at a high sentence level. Do you know a couple?
oh,
I can answer that one.
Okay.
Yes, so SLR just completed a flood study in the Sparkill Creek that's through the Resilient New York program. And Mark Carabetta is here and dropped a link in the chat to that study, which has been completed. So they're looking at flood risks and some specific interventions that might help reduce flooding in the future for the Sparkill Creek. I'll put a link to that study in the show notes, so to speak, and make sure everyone gets that in the email that will follow up. So I'm So glad, Jen, that you could be here with us this morning. We wish you all the best as you make a big move to South America, but hope you'll stay in touch with our watershed community here. It's really exciting to see a decade's worth of work on the Sparkill Creek Watershed. And I just want to echo, Jen's thanks to the Sparkill Creek Watershed Alliance for being able to leverage all of these partnerships and get all this amazing information into one place. It's really exciting to think about what the next decade might bring if we consider how the trajectory of this work is moving and what some of the improvements might be in the creek. So thank you all for joining us, and we hope you have a great day.
We are also taking a summer break, right, Emily?
We are. So we're taking our regular summer vacation, so to speak. We'll be back in September with the breakfast lecture series.
Thank you.
Great time, everybody. Thank you all.